Hello everyone, I am Mrs. Sneha Revankar, going to be teaching the subject Basic Electrical Engineering. The course code for this subject is APC 105. The teaching load for this subject will be 3 hours per week. Credits are 3. The prerequisite for this course is Fundamentals of Physics. The course objectives and outcomes for this subject are: objectives is what you are going to learn from this subject, what you will be have learned at the end of the semester is the outcomes. Objectives are to provide knowledge on fundamentals of DC circuits, single phase AC, three phase AC circuits and its application. Later you will be studying the basic operation and performance of single phase transformer and the fundamentals of DC machines. At the end of the semester you should be knowing for applying various network theorems and determining the response and the behavior. Then you should be able to analyze single phase AC circuits and three phase AC circuits. Later, constructional features and operation of single phase transformer and the working principle of three phase and a single phase machine. This is a syllabus for basic electrical subject. First you have prerequisite, which you are supposed to know, but I am going to cover the basic concepts of basic electrical engineering that you require for the subject as of now. Later module 1 includes DC circuits, module 2 DC circuits, module 3 is three phase generation, module 4 is transformer, module 5 is electrical machines, module 6 is single phase induction motor. You also have a self-study topic which you have to study on your own. The exam paper also contains some theory questions with no numericals in the paper, so you should be studying this as a self-study. The textbooks that are being recommended are as follows. There are n number of books. You can refer whichever you feel comfortable as per the topics given. This is the evaluation pattern. How is it overall subject being evaluated? The first CO is being evaluated to assignment test 1 and internal assessment test 1. What is the difference between assignment test 1 and internal assessment test 1 is assignment test is being given either batch wise or class wise, and then the paper is being checked or evaluated for 20 marks, whereas internal assessment test is the university internal exam which is being conducted in college, where the first CO is being evaluated for 10 marks. Similarly, the second CO is being evaluated for 10 marks for IA1 paper. Then assignment test 2 is the class test. Then module 3 is evaluate and analyze three phase AC circuits, assignment test 3 and internal assessment 2, which is of 20 and 10 respectively. Fourth module CO is operation of single phase transformer, where the evaluation tool is MCQ and internal assessment 2, which is again evaluated for 20 and 10 respectively. The working principle of three phase machine and single phase machine, you will be having the assignments being given. You have to write in a paper, that is a college paper, and submit it to the teacher accordingly, and it is being evaluated. MCQs are also being asked in that, so that evaluation is being done. Next is you also have a laboratory to be conducted once in a week for 2 hours. The course name for that is Basic Electrical Engineering Laboratory, and the course code is FEL 104. The credits for that is 1. The course objectives and the outcomes for that is the objectives of the basic electrical theory paper will almost be same, but only thing is whatever theory you have studied, that practicals you will be doing it or implementing it in the lab. First objective is to impart the basic concept of network analysis and its application. Second one is to understand the basic concept of AC analysis and its application. Third is operation of machines and transformer. Likewise, we'll be doing all the practicals, some hardware and some study experiment. So at the end of the semester, you should be able to interpret and analyze the behavior of DC circuits using the network theorems, then perform and infer experiment on single phase AC circuits and demonstrate the experiment on three phase AC circuits. This is, teacher will be doing the experiment, you will be noting down the data. Fourth point is performance of single phase transformer and machine. This is again a study experiment on transformer and machines. Next is for the laboratory, all these course outcomes are being evaluated in the form of lab that you have performed during the semester and the orals that is being taken. So the maximum marks for that is 25 marks. We will all discuss about module-wise detailed plan. Every module is having number of hours. For example, module 1 is a DC circuits where only independent sources are being discussed. What is independent sources? We will discuss in the later video. This is having 12 hours of study in which we are going to utilize those 12 hours in group wise. DC circuits, first we are going to study on Ohm's law, KVL and KCL, where you are using KVL and KCL theorems for evaluating mesh analysis and KCL nodal analysis. Then we are going to study on Thevenin's, superposition, maximum power and Norton's. Thevenin's and Norton's are the reduction theorems. Superposition and maximum power will go hand in hand. Ideal and practical voltage sources. What is ideal voltage source and the practical voltage source? Similarly, current sources for ideal and practical will be discussed. The next is source transformation. If you want to convert current source to a voltage source to a current source and find out the output value, then we are going to study this. Later we are going to study star delta, delta star transformation. This is all about module 1, which is being distributed among 12 hours. Next, in module 2, we are going to study single phase AC circuits, where first we are going to study the generation of single phase AC concept, then representation of single phase AC, V is equal, for example, V is equal to Vm sin omega t, and then understand its graphical concept, magnitude and mathematical form. Later we are going to study the analysis of single phase RLC. Suppose if we are connecting R with a single phase AC supply, what is the effect in the behavior of it in a single phase we are going to study. Likewise, analysis of RL and RC, analysis of RLC in series and parallel. Finally, we are going to understand series and parallel resonance in theory and implemented in practical. Later, components of single phase AC, real reactive apparent power, impedance triangle, power triangle, what is its need and its detailed idea, power factor and Q factor. In module 3, we are going to understand three-phase AC circuit. Likewise, as we have studied single phase, we are going to study three-phase, concept of Generation of three-phase AC, voltage and current relationship in star and delta connections. Suppose three-phase AC we have, how do we connect those three wires in star and delta connection, derivation of that and the problem solving for both the connections. We are also going to study the power measurement in three-phase balanced circuit. You have balanced and unbalanced circuit. We are all going to study that, and the only uh, method that we are going to study is 2 wattmeter method. In module 4 is the transformers, where we are going to study working principle of single phase transformer, EMF equation of it, and comparison between actual and ideal transformer, derivation for EMF equation, and problem solving. Similarly, we are also studying the phasor diagram and equivalent circuit study. And this is limited to only resistive load. We are not going to study for RL and RC. Then we are going to understand open circuit and short circuit test, which we are going to study in theory as well as in the practical.